with those things. So then let me start with some questions from electric potential. Okay, some questions. The numericals part for the half an hour. Okay. Please.
Ma'am, are those questions sufficient for tomorrow's exam?
Yes, dear. Yes.
Okay, ma'am.
Can I go with some numericals, or can I go with only the derivation part if you want? What do you want first? Tell me.
Ma'am, like first to teach us the derivation part, ma'am, then like we'll do 1 or 2 problems.
Okay. You are having what are the questions I solved in the classroom, right? All of you? I solved so many, plenty of the problems based on the all the chapters. Again, I send this 3 chapters numericals in your groups also. You are aware of that?
Yes, ma'am.
Yeah. Please go through that. So then we'll go with some derivation part. Eastern Bridge, some people are really, I don't know what happened with you guys. We'll go with that. Tell me first question. Eastern Bridge, huh? So here we are going to derive the balancing condition. Let me write here a balancing condition for Wheatstone Bridge, or let me say like Wheatstone network. Okay. Wheatstone network. So before going to that, we need to know about the 2 laws. Okay, so those are the current laws. Let me say it as the Kirchhoff rules. Okay, Kirchhoff laws or the Kirchhoff rules. Do you know the Kirchhoff rules for the electrical network? The Kirchhoff first rule, it is a loop rule. Junction rule. Tell me the junction rule. Yes. Yes, if taken when any junction or something. So here it is a I1, there is some I2, and 2 more currents are leaving here, I3 and I4. Okay, it is also leaving. So if you want to write the according to the Kirchhoff loop rule, Kirchhoff entering into the junction which is equal to the sum of the current leaving the junction. So the I1 plus I2 equals to the I3 plus I4. Can you able to get it? Yes or no? It is around 2 ampere. This is around minus 2 ampere. So I can write it like, so it is a 5 ampere, it is minus 5 ampere, right? So in any junction, okay, any junction, what are some of the current entering into the junction is always equal to the sum of the current leaving the junction. Okay, that is a loop rule. Okay, so if any let me take one resistor, one cell. Okay, so okay, so if I want to find out the what is the total electric potential electric potential in the loop, okay, it should be closed one. Okay, in any closed loop which is including the resistor cells, which is always equal to 0. So if you want to write the what is the voltage over here, or let me say potential difference across the resistor, let me write it as a VR, and here it is a VC. So if you want to write according to Kirchhoff loop rule means VR plus VC is equals to 0. So by using these laws, we are going to find out what is the balancing condition for the Wheatstone network. Okay, is it clear? So for the Wheatstone network, we required 4 resistors. Like this, I will take 1, 2, 3, and a 4. Okay. So in between, let me denote as the A, B, C, D. Okay. I have taken a closed loop. Okay. So here it is having the resistors like a R1, R2, R3, and R4. Okay. Clear? So now you can observe here. I will connect the one galvanometer in between the B and DN. Okay. So then now I'm going to connect it across the one battery, and now this is the key. Okay. So this is your Wheatstone network. Okay. Is it clear how to draw the diagram? Is it clear? So now the current is flowing like this, now like this, like this. So it will come here. 1 second. Hello? Yes? Yes? Now I am in class now. Okay, so the now current will come here, and the current will be coming here like this. Okay, so this is the Wheatstone network. Okay, now we need to balance the bridge, and we need to get the what is the balancing condition. Okay, so let me consider for the ABDA loop for sorry for the now it's connected. Okay, so let me draw a diagram. So I will take a one resistor over here, one more resistor here. So let me check one galvanometer. Okay, so let me denote as R1, R2, R3, and R4. Okay, so I will connect it across the one battery and the key. Okay, now current is flowing like this. Okay. Is it clear? The diagram part is clear for all? Yes. Please respond.
Yes, ma'am.
Yes.
Now let me take for the A, B, C, D. Okay. For the first loop, let me take for the ABDA loop. Okay, simplest way I will tell you. So try to write in within that way. Okay. So for this, I will use the Kirchhoff loop rule. Okay. So let me take here first loop A, B, D, A loop. Okay. So now you want to write the what are the voltage, right? What is the potential differences here? Let me write it as the V1. So let me write like a VG plus and V2 is equals to 0. This is the thing you know, right? This is according to Kirchhoff loop. Okay. So now try to write what is the potential difference across this resistor. So here current is the I1, here current is the I2, here current is the IG, and here current is the I4, and here current is the I3. Okay. So let me write according to Ohm's law. So the way V is directly proportional to I, right? Yes or no? V is the potential difference across the any conductor which is carrying current, which is directly proportional to the current. So then V is equals to I into R, right? So let me write here V1 is equals to I1 into R1. Okay, clear? So similarly here IG into capital G, and V2 is the I2 into R2 is equals to 0. So now see the directions. Let me start from A point. So it is in the same direction, and IG also in the same direction. I'll come to the next resistor, but it is in the opposite direction. So let me take I1 plus these two as a plus, and this one is in the negative direction. So then let me write it as the minus I2 R2 is equals to 0. Let me say it as this is the equation number 1. Okay. For the second loop, let me go for the second loop. Okay. So then for the second loop, I will consider from here. Okay. From B, C, D, B. Okay. Let me take B, C, D, B loop. So here V4 plus V3 plus VG is equals to 0. That's it, right? So let me write like a V4 as a I4 into R4, right? And a V3 as a I3 into R3 plus a VG as the IG into capital G is equals to 0. Okay. Then I4 is equals to, okay. So you can observe here, you are getting the current I4 from the I1 and you are losing at the IG. So I can write like I4 is equals to I1 minus IG. Is it clear? So then let me write like a I1 minus IG into R4. Okay. Plus I3. I3, you can observe here, you're getting the current from the IG as well as the I2. So let me write it as I2 plus IG into R3 plus IG into capital G is equals to 0. Okay. So now let me take from here. Okay. So now see the directions. So I will go to the C end, same direction. I4 is the positive and comes to the I3. Here it is a negative. Let me take it as the I3 as the negative. Clear? So then comes to the IG. It is also opposite direction. Let me take it as the negative. This one is also a negative. Okay. Is it clear? So I have taken like this. So let me split it and write it as the I1 into R4 minus IG into R4 minus I2 into R3 plus, minus IG into R3 minus IG into capital G is equals to 0. So now I need to balance the bridge. Okay. If I want to balance the bridge means, so how to do it? The balancing the bridge. Okay. Balancing the bridge means, so I need to take it the whatever the current you are getting in the galvanometer should be equal to 0. Means the galvanometer is showing the 0 deflections. So galvanometer is showing the 0 deflections means what? Galvanometer shows a 0 deflection. Galvanometer is a sensitive device which is going to find out the current, right? So if it is galvanometer showing the 0 deflection means the current in the galvanometer is a 0, means Ig is equals to 0. So now I'm going to balance the conditions, both the conditions I got for the first loop ABDA and the second loop BCDV. So Now, what are the trees is going to be 0? Just check it. For the equation 1, can I write it as I1 R1? Okay, it is that. And Ig into G, 0 into something, it will be a 0. So now please come to the second equation. So I1 into R4, okay, minus Ig into R4, it becomes 0. I2 into R3, okay, and minus Ig R3, it becomes Ig into 0 is also becomes 0, right? So now let me write it as the I1 R1, okay, I1 R1 minus, what you are remaining things, I1 R1 minus I2 R2, right? I2 R2 is equals to 0. So then let me write it as I1 R1 is equals to I2 into R2, okay? So please come to the second equation. You are remaining with here I1 R4 minus I2 into R3, right? I1 R4 minus I3 R3 is equals to, sorry, it is a I2, sorry, it's a I2 into R3, okay, is equals to 0. So let me write it as the I1 R4 is equals to I2 into R3. So let me denote as a, this is equation number 3 and this is equation number 4, okay? So now divide equation 3 divided by equation 4. So what is the equation 3? It is the I1 R1 divided by I1 into R4, which is equal to I2 into R2 divided by I2 into R3. So let me cancel I1 and I2 and I2 and I2, and R1 by R4 is equals to R2 by R3. Okay, so then let me write like R1 by R2 is equals to R4 by R3. Okay, so this is your, is it correct? Yes. So this is your balancing condition for the Wheatstone network. A balancing condition for the Wheatstone network. Okay, clear? Is this clear? This is a question. In the PU part, they may ask you direct question. Okay. So in the CBSE point of view, they may ask like some case specific question based upon this. Okay. Please go through this. If you're having doubt, please let me know.
Finish.
Done.
You draw some junction, no? Can you show that me?
Where? Before that. Which one? Which junction? Let's for some example, let's say.
No, nothing much.
So how many number of currents which are moving inside? I have taken as an example for the loop rule and junction rule. You can consider over here also. Okay. So what are the sum of the current entering into the junction, which is equal to the sum of the current leaving the junction. Okay. So that's what I have taken as a negative sign over here. Okay. And the second loop rule I have applied here. So the potential difference across the any which is including the registers are there, right? Register cells and which is including that is a 0. So you need to be close this circuit. One second. Close this circuit. I need to put a dot over here. Now this is closed. Oh.
Ma'am, next question.
Yes, sure. And one more thing, the cells in a parallel. You're feeling much difficult with that. Axial and equatorial plane, those all things are okay, right? Gauss law applications.
Yes, ma'am.
Ma'am, this is question number.
Check it, Weistrom Bridge from third chapter. Don't know the question number. I got the random questions from the students. That is the thing I have it doing. Yeah. Swami. Ouch. Then
Ma'am, how will it be the question paper pattern, ma'am,
For whom?
for tomorrow's term exam?
For whom, Ray? PU students or CBSE?
PU,
PO, ma'am.
1 marks, 2 marks, and 3 marks, and 5 marks, and numericals. 1 marks questions 4 or 6, 4, and 3 marks questions 2. 3, if they will give you, you need to write 2, and the 2 marks questions 3, you need to write 2, and the 5 marks questions is a 2, 1 you need to write, and a numericals. Okay?
Okay, ma'am.
Have you written the unit test one? Same pattern. Do you
Yes,
have
ma'am.
unit test paper 1? Do you have?
Ma'am, this will be for 50 marks, no, ma'am?
35.
35?
No, ma'am, 50. Because today both the exams were for 50 marks, ma'am.
Sir, that
But
is
is
math.
maths and second language.
That is
so that's
only
why.
for the.
Ma'am, 1 mark, how many questions, ma'am?
4 questions.
3
Ma'am,
marks.
UT1 paper will be there in Zoom, no, ma'am. No, this one class.
Google
Google
Class.
Classroom, no, ma'am.
No, you are writing in a
No,
offline.
ma'am, you asked UT1 paper, no, ma'am. That is right.
Uh-huh.
Online we wrote.
Yeah, unit 1. Yeah. You have that paper?
Yes, ma'am.
Yes, check it. Same pattern.
Unit 1 we wrote in Enlearn app, no, ma'am, like we submitted.
Don't you have taken any screenshot of that?
Ma'am, for CBSE, what is the pattern?
CBSE pattern.
Ma'am,
You're having 4 sections. Okay. In a first section A, you will be having 25 questions. You need to attempt 20. Okay. So it's around 0.5 into 20. Okay. How
10.
much? 10 marks. Okay. In the part B, you are having 24 questions. You need to attempt 20. Okay. So here 1 marks question each is a 1 into 20. It is around 20 marks.
20 marks.
Okay. In the next one, you are having like One second. Let me check. 0.5 into junior sections.
Ma'am, how many marks it will be for this one for PO, ma'am, for 3 marks? How many questions will come, ma'am, for 3 marks?
What, ma?
How many questions will come for
The
3
question will be
marks?
coming for 3 marks, he's asking.
3. Choice will be there.
Okay.
5 marks, how much, ma'am? 2 or 3?
2, 1 unit at a.
Okay. You'll be having options will be there for 5 marks, no, ma'am?
Numerical 1 and a 5 marks question, long answer question 1 or 2. It based on the, actually in these chapters you will get the maximum 5 marks questions. The pattern will be like that. So then you will
What,
get,
ma'am?
okay,
Can you tell again, ma'am?
I'll tell you. Wait, I'll tell you. So for the CBSE, please look at here. Okay, 20 questions they will give you in term. 25 questions they will give you. So you need to attempt only 20 questions. Okay, 0.5 marks each question. So then you will get around 10 marks, right? So then, and the section B, you are having 24 questions. You need to attempt 20. So then, how many marks here? 1 mark into 20, it is around 20 marks. Okay, and the section C, you are having around 6 questions. You need to you are having 6 questions. You need to attempt 5 questions, 1 mark each. Okay, so that is a 5 mark. 1 mark each. That is a 5 mark. So here in the section A, you will get like a definitions, okay, yes or no questions, some some formula based one, okay, and some direct questions in the part A. In the point B, like a long answers questions from the NCERT plus Oswald publications. Okay, go with the Oswald publications. Okay, in the part B itself, you are going to get the assertion and reasoning questions. Okay, assertion and reasoning questions from the Oswald publication. Please go through it. Okay, in this section C, you are having 5 questions. One question is the MCQ, and one more question is the case based. Okay, which is included with the 4 questions. Are you getting my point? One is some case based questions. You know the case based questions, right? So something they will give you the some theory or some junction like this. Okay, some junction like this. So they may ask like, what is the potential at the loop A? 4 options. What is the potential at a loop B? Okay. So then what is the current going through that? What is the balancing condition? This kind of a question will be there here. Okay. So there you are going to write for the 5 mark. Okay. All are MCQs only for the CBSE. Okay. Is it clear? Is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
So I will tell you for the PU board. Once again.
Ma'am,
Yes, ma'am.
ma'am, will you please send us the important questions for state?
I
Yeah.
already sent you in a group, right? I already sent you in a group. Once you please check it. If you want, I will send you again now.
Ma'am, please send it again.
Yeah, sure, sure.
Thank you, ma'am.
Yeah, I'll send you now. Maybe you're confused with so many things in a group.
Ma'am, can you just tell the pattern, ma'am?
Yeah,
for
first thing
QC,
I will send.
Yeah, ma'am.
What, ma?
QC pattern.
One second. Oh my god. This is for the CBSE. Any questions here?
No, ma'am.
No, right? So go for the PU board. Okay. PU board physics, 1 mark questions, 5 questions. Okay. There is no choice for the 1 mark. Okay. 5 marks. Okay. 2 marks questions will be there. 5 questions they will give you. 5 questions they will give you, but you need to attempt 3. Means how many marks here?
6 marks.
6 marks.
Okay. Then 3 marks questions, 5 they will give you. You need to attempt 3. How many marks?
9 marks.
9 marks.
9 marks. Okay. And the long answers questions. Long answer questions, they will give you
Ma'am, in the
3
sense, long answer, matlab, you will be having derivations or how, ma'am?
derivations only. Only derivations.
Only in this
Okay.
3 marks, only derivations will be coming.
No, no. In the 3 marks question, they may ask like a difference. Okay. Some derivation
Okay,
part.
theory part.
Theory part. Only theory
Okay, ma'am.
part. These 2 are the
Okay.
theory part only. Okay.
Okay, ma'am.
And the
Fine.
5 marks questions, long answers questions. Okay, long answers question, they
ma'am.
will ask you 3. You need to write only 2. How many marks? 10 marks. Okay. And the next one, that is a separate section, numerical problems. Okay, numerical part, they will give you 2. You need to write 1.
Anyone.
Anyone. Okay, anyone. Okay. So that is a 5 mark. So it is around 6, 15, 10.
Totally only 1 problem will be coming.
35 marks.
Yes, 2 problems. One is from the current electricity, another from the moving charge.
Moving charges and magnetism.
Okay, clear. So
Other than
here,
that, everything is theory.
huh,
Or like
For
5 marks.
yeah,
Okay, that's what
5
for you
marks
only
long,
5.
yeah, in the long answers questions, there is no numerical part. In the long answers question in 3 marks and 2 marks, there is no numerical part. Okay, they may give you like a small thing. Okay. Anyway, you are having the options here. Are you getting my point?
Yes, ma'am.
Okay. So the theory part is a very important for the PU.
Ma'am, can you tell again, ma'am? This my internet got disconnected.
Which one, ma? Which one you want?
About problems and stuff like that. No, ma'am.
Okay,
Like,
here.
only 5 marks will be having problems, ma'am. Other than
Yes.
that, no.
Numerical part is around only 2 questions they will give you, you need to attend only one.
Everything theory.
Yes. Long answers questions. Here it is the derivation part.
Derivation part.
Okay, in the derivation part, get it from the 3 chapters. So first chapter, axial line, equatorial plane. Okay, which is to question one question. Okay, or Gauss law application, right? The thin rod and a sheet. Okay. Next one, when you go with the electric potential, in the potential due to point charge and the capacitance of a parallel plate capacitor. You are clear with the questions here. So axial line, equatorial plane, Gauss law, thin rod and the sheet. Sheet, it is a very small, they may give you for the 3 marks. Means in the first chapter, you are going to get the 3 questions only. Axial line, equatorial plane and a Gauss law, thin rod problem. Okay, if you practice this, you will get 5 marks. Compulsory question. Are you getting my point?
Yes, ma'am.
3 questions they will give you. And the next one, potential and the parallel plate capacitor for the second chapter. Okay, potential due to a point charge and a parallel plate capacitor, capacitance of a parallel plate capacitor. So next one, you will go with a moving charges magnetism. Moving charges and a magnetism. In the moving charges and magnetism, you are having only two derivations. The long answers questions are the only 2. Okay, so many are there, but they are not going to ask that. They may ask in the 3 marks and 2 marks, not that much lengthy. Okay, here you will get like a that right?
Yes, ma'am.
Yes,
Is
ma'am.
that magnetic field due to the current carrying a loop? Okay, circular loop. Who is that? Please mute your call. Who is that? Okay, so the magnetic field due to a current carrying a coil, and the second one is the parallel conductors. Okay, you can see here parallel conductors. You're going to write here you're going to find out force per unit length. Do you remember? So within these 2 questions you'll get. So means first you need to learn axial, equatorial plane, okay, potential and a parallel. So I'm bit confused. You are not confusing. So I'm bit problem with the electricity. Okay, if you got the numerical part over here, you won't get any derivation part here. Okay, that is the thing. Clear? If you want, I will send you the things also.
So the question paper is enough, ma'am, for PU board
Yes.
that you have sent to.
Am I going to send whatever you told?
Ma?
Whatever you told, are you going to send it?
Which paper?
No, just now you told few questions, right?
I
Can you
already sent you in the group. I'm discussing these points only from the past 15 to 20 days. I have stopped my syllabus 15 days back due to this.
Mom, it's a bit confusing. Can you just tell in order once? I'll just write it out.
Madam, I already sent you in the group. Have you checked it? I have sent like a...
Every day we get a lot of messages, so it's kind of.
I don't know that.
Mom, question paper,
Not question paper. I'm sending according to the syllabus wise and the according to like a chapter wise I'm sending, right? I have sent the numericals according to chapter wise, and I have sent the long answers questions separately and the short answers questions separately, and a 1 mark questions from the CDF and the definitions part is also separately in your groups. And I have sent the CBS part also, Oswald publication and the NCERT e-solutions I have sent separately. Okay, if you want, after this class, I will send you again. Okay, I'll send you all the PDF what I have sent. Okay, I'll send you again now after 8 o'clock. Okay, is it clear? Anything apart from this? If you want, let me know. We'll send you now.
Ma'am, numericals from which chapter, ma'am?
Numericals from the first 3 chapters.
Okay.
Okay, I'll send you once again. If you want, NCERT total solutions I will send you. Okay, that is a handwritten book only. I will send you. Next, Oswald publication I have sent. Again, I will send you. And some MCQ questions I'm having, I will send you that. Okay, the question paper, some sample question paper I'm having for the CBSE, I'll send you that. And for the PU people, I have sent again. I will send you long questions, numerical problems, the 5 marks and 3 marks questions, and the 1 marks questions from your. Please go through the CDF book once. Okay, if you're free, please go through the CDF book once. So there is some direct definitions you are having. Okay, please spend this some half an hour to 40 minutes with that. So it will be really helpful for you people, especially CBSE students. Please go through it. And then for the PU students, 1 marks 5 questions are there. Please go through the CDF book. Okay, is it clear?
Yes, ma'am.
Now it is a clear about the how you are going to get the questions.
Yes, ma'am.
Is it clear for the both boards?
Yes, ma'am.
From which chapter you are going to get? Can I tell you this?
Can you come again?
I will tell you from which chapter you are going to get it also. Chapter. It is around 8 marks. As per board chapter, it is also 8 marks. The current electricity is at 13 marks, and the 4th chapter is around 10 marks. Okay, so I will write it here: 1 mark, 2 mark, 3 mark. Okay, a 5 mark long answer question. Okay, and the 5 mark numerical. Is it okay? Like this, it is okay?
Yes, ma'am.
1 marks question from the first chapter, 1. Okay, a 2 marks question 1 and long answer question 1. Okay, in 2 marks questions, what are the things you will get in the first chapter? What are the properties of charge? What are the electric field lines? Why the electric field lines are never intersect each other? What is the Gauss law? What is the Coulomb-Inverse square law? What is the Coulomb-Inverse square law in a vector form? Okay, these kind of questions. Okay, clear? I'm telling you questions also. 5 marks long answer question, axial line, equatorial plane, and the Gauss law thin rod. Gauss law application thin rod is there, no? Within those 3 questions, you will get 1. Okay, there is no numericals. Okay, and go for the second one, second chapter. Here, a 2 marks question 1. Okay, a 5 marks, 5 marks question, that is a numerical. Okay, numerical, and 3 marks question. Is it clear? In the current electricity, you get 1 marks question 1. Okay, and the 2 marks question 1, and the 5 marks long answer question, and the also. Okay, I have and the marks question also, and 3 also, one numerical also. Is it clear? Okay.
Yes, ma'am.
So this is according to board weightage. Okay, and the 4th chapter, 2 marks question, 3 marks question, and 5 marks of numerical. Okay, numerical. Okay, so now it here. This is according to your board weightage. Okay, board weightage. This is the must and should they should give you. Okay, are you getting my point? From all chapters, you need to cover all the 3 marks and 2 marks. So 2 marks questions 5, that is the 10, right? Sorry, 6. So here around 6, here it is 9. So around 15 marks from the only 2 and 3 marks questions. Is it clear? So 5 marks long answer question. Please go through the first chapter, 3rd chapter. My suggestion is that learn all the things in the first chapter and 3rd chapter. In 3rd chapter, you are having plenty of that. In the 4th chapter, you are having only 2 derivations. Are you getting my point? You need to do the smart work now. Okay. So 5 mark compulsory question should be there, and the 1 compulsory question from the 3rd chapter means please go through these 2 questions, 6 derivation from here as you wish. This depends on how you work. Okay. Okay, and the 5 marks numerical part from these three things. Okay, and the my question is, my guess is correct. So you will get the 2 questions from here, 2 questions from, and from 4th chapter or the 2nd chapter, or 1 question from here. That's it. Did you got my point?
Yes, ma'am.
This is according to the board. This is the board blueprint. Okay, according to this only they need to give. Clear? Now it is clear how you are going to get your paper. CBSE board and both the things.
Yes, ma'am.
Yes, fine. So then, can I go with this or with this? From this, you will get 2 questions compulsorily. That is your Wheatstone bridge and cells in a parallel. Compulsory. But
What, ma'am?
the
Can you
questions are
come again?
very
Can you tell this
tough.
again, ma'am?
Yes, ma'am.
Which questions can you tell it
Wheatstone
again?
bridge,
I couldn't-
cells in a parallel, and the electrical conductivity in terms of relaxation. Those 2 derivations only tough. And the remaining part, like a resistors in a series, parallel, those are easy things. Have you seen that? Resistors in series and parallel. Have you seen those questions? So those are very easy. They are not going to ask for the 5 marks. They may ask in the 3 marks and 2 marks. Okay. In the 5 marks, I'm expecting that Wheatstone bridge, cells in a parallel, or electrical conductivity in terms of relaxation type. 3 questions. Okay, here 3 questions. And from the 4 chapters, what is that? Magnetic field intensity due to a current carrying a loop. Okay, and one more thing is the parallel conductors. So within these 2 questions, you will get 1. Okay, so means it is around 10 marks, and here it is a 5 mark. Okay, is it clear? Is it clear?
Yes,
Yeah,
ma'am.
ma'am.
Okay. So now we'll go with the 3 marks and 2 marks part is okay, right? Will you do it right? Please go through your material. It's enough now. It's really enough. And which point you want, let me know. I will go with that. So it's in a parallel. Let me finish this chapter. So it's in a parallel, and that electrical conductivity in terms of relaxation. Okay, can I go with this?
Yes,
Yes.
Yes. So cells in a parallel. So I will take 1 cell and 2nd cell. Okay, I will connect parallelly. See here, I connected parallelly. So this is the first cell, and this is the 2nd cell. So let me denote it as some points like A, and this is the B1, and this is the B2, and this is Cn. So let me draw one equivalent cell over here. So let me draw it as A and Cn. Okay. So this is the first cell is having the EMF of E1, and it is having the EMF of E2, and this is the some equivalent cell. Let me write it as the E equivalent. And similarly, it is having the some internal resistance R1. Here it is a R2, and here it is a R equivalent. Okay. So now how the current is flowing? So let me write it as a I1, and here it is the I2. Okay. Is it clear? So now I need to check when the cells are connected in a parallel. Okay. So whatever the potential difference across the ends will be same. V is same. Please keep it in a mind. Okay. The potential difference across the cells will be a same. So now let me take it 2 cells which is having the EMF E1 and E2, and internal resistance R1 and R2. This explanation also you need to take in your long answer question. Okay. So now let me take it for the B1 end. Okay. So the potential, the terminal difference between the first cell. Okay. So let me write like V is equals to VB1 minus V. So I will write for the first cell, then V is equals to E1 minus I1 into R1, because current is I1 and to R1. So let me write for the I1 equation, then I1 R1 is equal to, it will become plus, right? 1 minus V. So then I1 is equals to E1 minus R1. Okay, is it clear? Similarly, I will write it as the I2 is equal to. Is it clear? So now let's check what is the total current. The total is equal to I1 plus I. So let me substitute that. I is equals to, and I1 is the E1 minus V divided by R1 plus, and I2 is equals to E2 minus V divided by R2. Then I is equals to E1 by R1. Let me separate E1 by R1, a V by R1 plus E2 by R2 minus V by R2. Clear? So let me write separately all the EMF terms one side. E1 by R1 plus E2 by R2 minus V as a common, then 1 by R1 plus 1 by R2. Okay, so let me take a LCM. So E1 R2 plus E2 R1 divided by R1 into R2 minus V, R2 plus R1 divided by R1 into R2. Okay, let me go to next page. So can I take a common 1 by R1 into 1 by R1 in both the terms? So then we write that multiply by R1 into R2 is equals to, I have to take here, that's it. So then E1 R2 minus E2 R1 minus V minus V so then V is equal V into R2 plus R1 equals to E1 R2 E2 R1 minus I into R1 into R2. Then V is equals to, let me write V only, E1 R2 E2 R1 divided by R1 plus R2. Okay, so minus I R1 into R2 divided by R1 plus R2. Okay, clear? So then let me write for this one for the equivalent, what is this cell? So then V is equals to E equivalent minus I into R equivalent. Okay, so let me compare these two equations. So let me write it as E equivalent is equals to E1 R2 minus E2 R1 divided by R1 plus R2. So similarly, R equivalent is equals to R1 into R2 divided by R1 plus R2. Okay, so this is the E equivalent for the and R equivalent for the two cells. If number of cells are connected, okay, if the number of cells are connected, so then how you're going to write it? So then E equivalent is equals to E1 R2 minus E2 R1, right? Minus of E2 R3 like that. Okay, so or it continues, right? So then, so now you like this. So you can end up here. So then ask the question like this. So expression for the equivalent EMF, and internal resistance of the two cells are connected in a parallel. Two cells are connected in a parallel. Clear? Please take it. If you're having problem, please let me know. I'll explain once again. For PU people, I have sent now. I have sent you some questions now. Please check it. 2 marks, 1 marks, 2 marks, all the things, and numericals also. You can check it.
Yes, ma'am.
Okay, PU done.
Ma'am, if you practice that, how much we'll get, ma'am?
35.
From that only they'll get questions, ma'am.
Yes, obviously.
Okay, ma'am.
Forget apart from that, let me know. I'll put objection. Then PU, for the PU has sent it now. For the for the CBSE board, say for the CBSE students also I should send. Please take it fast. Done. I have sent it. Please check it. Anything apart from this, please let me know. I'll send you now. Please check your groups once.
Got it, ma'am.
Got it. Please check it. Anything apart from that, please let me know. I'll send you once again.
Major chapters are first and third, no, ma'am.
All chapters, man. This first part, first term examination is really weightage chapters according to your board as well as the labs also.
Okay, ma'am.
Please concentrate, try to understand. Anything you want apart from this?
You can send them if there's anything else.
Yes. I've sent it already, but if you want anything. Okay, please check it. Please check it once. For the PU people, I have sent the NCERT questions, e-solutions from the 3 chapters is enough. Okay. Then go for the PU board of physics questions along with your chapters. Chapter wise I have given, please go through that. And after that I have given for you people is enough. Okay. It's enough for the PU. So I have sent the scheme of paper also, 1 mark questions and how you're going to read also. So that is about 35 marks. And after that I have sent some physics MS PDF. That is your sample question paper, marking scheme and sample question paper for the CBSE students. Okay. For the CBSE, Oswald and NCERT Exemplar, and what I have sent individually, those moving charges and magnetism, electric charges, current, electricity. So those chapters, NCERT solutions is enough. Okay. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am,
Yes, ma'am.
for that question, ma'am, when is the 1 second, ma'am.
Yes, ma'am.
Ma'am, when will the electric flux be negative and positive? What is the answer, ma'am?
Electric flux will be positive and negative. Okay.
When will it be positive and when will it be negative?
Okay. Electric flux. What do you mean by electric flux?
Ma'am, the number of electric lines of force passing through a given area perpendicular.
Not
Where
given area. So it is a unit surface area. Unit surface area means the length and breadth should be a 1 meter and 1 meter. So if you take a area over here, length into breadth, so then length is a 1 meter and the breadth is also 1 meter, means the area will be 1 meter square. Okay. So how many number of electric field lines which are passing through the unit surface area, that is your electric flux. Okay. So if you want to calculate the how many number of electric field lines are passing through the for any unit surface area. For any unit surface area means you will take it as for the uniform charge distributed particle, like a spherical shell and the hollow shell and the cylindrical one and the sheet. Okay. So if you take the any unit surface over there, so if you calculate it over here, it will be constant for the throughout the system. So that's what we'll take it as the uniform charge density. Okay. Uniform charge density means, so if you calculate the charge over here, it will be equivalent to the all the ends of the body. Okay. So for that, we'll take the only uniformly charged particle or bodies for the to calculate the electric flux. So here I will check the how many number of electric field lines which are passing through the surface. Okay. So that is always is going to be denoted as a E. So that is always directly proportional to how much electric field you are applying. Okay. How much electric field is you are applying, and it is also directly proportional to the area. Okay. Which area you are taking. Okay. EA cos theta. Okay. So then, so if I want to write the where electric field and aerial vector both are surface aerial vector. Okay. aerial vector, both are vector quantities. So let me write like a E vector dot A vector. So now let me check with when the electric field is like this, but aerial vector is like this, means then here the angle between the electric field and aerial vector is a 90, right? So then let me write it as the phi is equals to EA cos theta. Okay, when the electric field and the aerial vector are perpendicular. Perpendicular means the theta is 90. So then I can write like flux. Here it is the electric flux phi E, magnetic flux phi B. Okay, then EA cos 90 degree. What is the cos 90 value? What is the cos 90 value? Zero. Then next, let me take a electric field is like this and the aerial vector is also like this. So through that, so the maximum number of electric lines can pass this area, right? So then I will write a phi E is equals to EA cos theta. Okay. So when E vector and aerial vector are parallel. Parallel means theta is equals to 0 degree. Then phi is equals to EA cos 0 degree. Then phi is equals to E into A cos 0 means 1. So then phi is equals to EA. This is your maximum value. Did you got the answer? Who
Yes,
asked this
ma'am.
question? Did you got the answer?
Yes, ma'am.
Is it
Ma'am, so
clear now? Yes.
if the question is like electric flux for maximum and minimum, then also we have to do in the same way.
Same way.
Okay, ma'am.
Okay. Is it clear?
Yes, ma'am.
Okay. So one more thing apart from this, please go through the equatorial plane thoroughly, equatorial plane and axial line. Please practice those, the diagram part. The diagram part is the most important thing. Okay, if you are missed with any direction part, how the electric field lines are moving, so that will be different part. Okay, you are never going to get any single marks for that. Okay, if you change the sign of the electric, how the electric field lines are flowing. Okay. So one more thing, please go with the diagram part of a electric field line. Okay, so the how the electric field lines are flow from the positive charge to the negative charge, and how it will be happen in a both positive charges, both negative charges in the electric dipole. Different cases are there, right? I have given already in the regular classes. Please check it. Okay, please go with that. How the electric field lines are moving from the one point to the another point. Okay, anything apart from this? Is it clear? This all part? What?
Yes, ma'am.
This one emotional. Okay, that EMV not there. Induction part not.
Ma'am, I had one doubt, ma'am.
Yes, ma'am. CBSE?
Yes.
Yes,
Ma'am,
yes.
there is a question in CBSE 19
Yes.
question. The small angle between magnetic axis and geographical axis at a place is.
That is from magnetism and matter, right?
Yes, ma'am.
Till you are having up to moving charges and magnetism, not matter.
Okay.
Okay, please go. Don't go behind that.
That's why I think.
Up to MCG. Up to moving coil galvanometer, that's enough.
Okay.
Up to. Okay. So the geographic axis and all that is included with your electromagnetic induction. Don't go with that. Okay, please go through only the 4 chapters. So the most important part from your current electricity, please go through the cells, series and parallel connection, resistors in series and parallel, drift velocity, mobility. Within those 2 questions, you will get one. And electrical conductivity in terms of relaxation. Yes, ma'am?
Resistor series and parallel is not there, no, ma'am?
Not there, not there, not there.
Yes.
Okay.
Cells are there, parallel and
Cells
series,
are
but
there. Cells are there.
not there.
Done? Anything apart from this? CBSE people who are there here?
Ma'am, capacitors is there, right? Series and parallel. Okay, ma'am.
Yes. Capacitors in series and parallel. parallel plate capacitor, capacitance of a parallel plate capacitor also.
Okay, ma'am.
Ma'am, can we bring phone tomorrow to class to revise this, ma'am?
Yes. Anyway, you are having exam at 10 around, I think. They have postponed your exam. Right? They have mentioned the groups also, I think. Let me check. Dear students, tomorrow you have the physics exam at 10 to 11:30. Then 8:30 to 10 I will be free for you people if you want. I'll come to campus by 8:30. If you want, you can come to the campus early and you can clear your doubts by 8:30 to 10. Anyway, your exam from 10 to 11:30. If you really want, I'll be free at that time because I'm having junior sections also. I need to go for that. If you want, I can make it free at that time, 8:30 to 10. Okay. 10 to 11:30, 1.5 hour exam. Hello. Yes. Yes, tell me. Yes, ma'am. No. First go through these things and go through the at least level 1 problems. Okay. Yeah, go for that. If you're having that, please send me the copy. Okay. At least from the first 4 chapters. Okay, fine. Let's tell me. Is it clear? Tell me what you mean by electric dipole moment. Sorry. Magnetic dipole moment.
V is equals to Q.
Huh? Magnetic dipole moment.
The product of magnitude of either charges dipole.
Hey, that is dipole moment. What is solenoid and toroid? What is solenoid and toroid? This is compulsory question, you will get it. What is solenoid and what is toroid?
Ring wounded by a wire is toroid.
Cylindrical coil, you can generally define some cylindrical coil which is wounded by the spiral one. You can see it in your speakers and all, right? This kind of stuff. So in the speakers, in the little earphones also you can find this kind of stuff. Those are the made up of solenoids where the magnetic field is converted into the electric field there. So the toroid means it's like a bangle shape. Okay, please keep it in mind like that. So it is some spherical shape. It is wounded with thick copper wires. Okay. So please try to remember like that. At least some difference between the solenoid and the toroid. What do you mean by Lorentz force? Yes. What do you mean by Lorentz force? Who are there here? Aditya, Sonali, Jayant. Just tell me. What do you mean by Lorentz force? Ampere circuit law, Biot-Savart's law. Main things only you don't know. What you'll do it? What you'll do it? Ritisha Reddy Konda.
Yes, ma'am.
Yeah, tell me the Biot-Savart's law, ma. I'm telling you now itself, I'm never going to check your papers tomorrow. I'll directly send you to the board. They will correct it. We are not going to do the corrections also. The physics part, we won't do it. Try to write something in your paper. If you're really done. Anything apart from this? Any other questions? Any other questions, ma? Is there any part to discuss? Please let me know. Done?
Yes, ma'am.
Okay, fine then. Can end the class for tomorrow today. We'll meet in the tomorrow's first class. Okay?
Yes, ma'am. Thank you, ma'am.
Yeah, thank you.